in this chapter again, some application of trigonometry. We are doing another module where we are again learning a sum based on application of trigonometry. Let's see the sum, and it's a beautiful sum. Let's see the sum. It says a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Now, when we read this particular sum, we at least realize that there has to be a tree first, right? So, we have a tree here, right? So, this tree breaks due to storm. So, first of all, we have a tree and we just take this as a perpendicular segment. You remember? Yes. And let's say this segment we have taken as AB. So, AB is nothing but it is the length of that particular tree. This tree breaks due to storm. So, that means it is going to break. It is not uprooted. It is going to break. So, it will break at a particular point. And let's say we have taken that point to be C. So, C is the point where the tree is going to break. And the broken part bends. Now, the broken part bends so that the top of the tree touches the ground. So, now the tree breaks. See, the tree broke, right? And the top of the tree touches the ground, right? Making an angle of 30 degrees with it. That means that broken part which you see there, it has fallen and the top touches the ground, making an angle with, that means that top of the tree is nothing but the D, and the angle which is there, which is made with the ground, is given as 30 degrees. This is what is given in the sum. You understood what we are supposed to draw? Which angle is 30? Easy, right? Let's move ahead. The distance between the foot of the tree is A, and to the point where the top touches the ground, and the point where the top touches the ground is D. So that means the distance between A and D is 8 meters. This is what is given to us, right? So we write the 8 meters. Easy, simple. Find the height of the tree. It's so easy. That means you have to find the length of AB. Easy, simple. We understood what we are supposed to draw. It's so easy to draw this. Now students, understand, if you think of BC and that CD, that segment, isn't it the same? It's the same BC which has taken the position CD now. That means both are equal because it's the same segment. So we know that BC is equal to CD. So this is what we actually have in the sum. This is what we are supposed to draw. So we have drawn this. Now our job is to think of getting that AB. But before that, let's describe the figure. So we write there, here what we have is, we have that AB, and AB represents the height of the tree which breaks at point C. Right. So if it has broken there at point C, that means that BC represents the, yes, that BC represents the broken part, and that AC which you see, AC represents the length of the unbroken part. That's the description which we have written here, right? And we have an angle given there, and we have the length of AD as 8 meters. This is what we have. Now what do we need to find? We need to find the length of AB. Now observe AB and tell me, AB is made up of how many segments? It's made up of two different segments, AC and BC. So that means we are saying that we know AB is equal to AC plus BC. So in order to get the length of AB, we require two lengths. We require the length of AC and the length of BC, right? So that's our job, right? Beautiful. Now let's focus on AC first. Now AC we can find because AC belongs to that right angle triangle, CAD. Observe, yes. So first of all, observe, to find AC. In this triangle, do we have an acute angle? Yes, we have an acute angle D given to us. So observe that. For that angle D, observe that opposite side which we need to find, that is AC. We need to find, right? That's the opposite side. And the information which is given AD is nothing but it is the adjacent side. That means in this triangle, we are talking about opposite side and adjacent side. So which ratio are we talking about? It is nothing but it is going to be tan, and so we are going to use tan of 30. So we write there tan of 30 is equal to opposite side upon adjacent, that is AC upon AD. Now from the table we know that the value of tan 30 is nothing but it is 1 upon root 3. We substitute that value there, and the value of AC we don't know, keep it as it is. The value of AD is known to us as 8, so we write there 8. Now we get that AC is equal to 8 upon root 3. Now, we will not solve this further right now. That means you would be thinking, why are we not rationalizing the denominator? We can do it. But we need to find the length of BC because we have to add. Then we will do the rationalization at the end. Right? Let's keep it as it is. Now we move ahead. Now we need to find the length of BC. If you look at BC, you can find BC directly because BC doesn't belong to that right angle triangle. But we know that BC and CD are equal and CD belongs to that right angle triangle. So let's do that. So now we are going to do that. So in that, let's find the length of CD now. So what are we going to do? Consider that right angle triangle CAD. And now here we are going to say angle D. For that, we need to find CD. Yes, we know that the adjacent side AD is given to us. And we need to find what? We need to find CD, and that CD is nothing but it's a hypotenuse. So we are talking about adjacent side and hypotenuse. So again we know adjacent side and hypotenuse. That means the ratio which you are going to take is nothing but cos, right? Adjacent side upon hypotenuse. So let's do that further. So we write cos of 30 is equal to AD upon CD. Now we know from the table that cos of 30 is nothing but it is root 3 upon 2, substitute that value there. That is equal to AD, we know it is nothing but 8 meter, and the value of CD, we don't know. But we know CD and BC are equal, so we just write there. Instead of CD, we can write BC because that is what we need to find. So we get root 3 into BC is equal to 8 into 2, that is 16. So we get BC is equal to 16 upon root 3. You know what? Now we got the value of AC and we got the value of BC. Now it's almost done. It's so easy. Now we just need to add it. Let's do that. So now we write that height of the tree is nothing but it is AC plus BC, which is equal to the value of AC is 8 upon root 3. The value of BC is nothing but 16 upon root 3. Now you know what? That is why I said don't rationalize. Let's see what values we have got. Both the denominators are same. So let's add it now. So what do we get here? We get 8 plus 16 upon root 3. Right? So what we get is 8 plus 16 is 24, 24 upon root 3. Now, do we need to rationalize? Yes, because it's going to be the final answer. We are going to simplify it further. So denominator is irrational, rationalize it. So for rationalizing, we are multiplying and dividing by root 3. So we write 24 upon root 3 into root 3 in the numerator, into root 3 in the denominator. So now what we have in the numerator is 24 root 3 upon in the denominator, root 3 into root 3 is how much? 3, right? So now do the cancellation there. It is 3 ones are 3 eights are. So we get that is equal to 8 root 3. Is it over? No. We have the value of root 3. What is that? It is 1.73. Substitute that value there. So now we multiply 1.73 into 8 is nothing but 13.84. So we got the height of the tree. You know what? The sum is almost over. So now we get the final answer there. Therefore the height of the tree is 13.84 meter. Wasn't that easy? A very important sum. Easy, right?